All right. Good evening, everyone, and welcome to session 20 of the data science program. We are actually rounding up. We are almost at the finish line, so you should be proud of yourself because you've actually been persistent and also consistent with learning. All right, it's actually not an easy thing to do, coupled with the fact that we all have a lot of other responsibilities and things that might want to take our time. But sticking up till this time shows your commitment, and it's something to be proud of. Yeah. So by this time next week, we're going to be having our last class. Yeah. So next week is going to be our last class, so you can have time to do your projects. All right. So you have enough time to go through the materials and revise what you have to revise and focus on your project. All right. So we are going to be rounding up with the class next week. So yeah, that is it. That is it. We've actually I can just remember starting these cohorts a few weeks ago, and we are here already. Time actually flies. So yeah, I'm happy to have you once again in today's class. So as you can see on the title, we have hyperparameter tuning. So today we're going to be looking at something different, although it's a continuation of where we stopped, but a different topic altogether, right? So you can't hear me, Olabode. Please let me know if it's general, so I can adjust myself. Okay. All right. So I think it might be from your own end, because I think other persons can hear me clearly. All right. So yeah, that is it about that. That is it about that. I think I've told you all about what we have to do regarding the schedule, the remaining schedule for this program. So I'm going to go right again. And as I said last week, that this week is going to be the week that you'll be having. This is going to be the last assignment for this program. So after this week's assignment, you won't be getting any assignment again. So starting from next week, I'll be introducing us to the project that you'll be doing. So you'll be getting a project document highlighting the details of what you are required to do in the project, and the submission guidelines and the or everything you need to do, everything you need to know regarding the project will be on that document. But we're also going to talk about it. I will talk about the project as well during class or after our class next week. So it's very essential that you participate in this project. So it will help you gather everything you've been learning so far, right? It's going to help. We are going to just summarize, just like a summary of everything that you've been learning. And if you've been consistent with the assignment, if you've been doing the assignment that has been given weekly, the project is not going to be a problem for you. It's not going to be an issue. There is no much difference between what is going to be in the project and what you've been having as assignments. All right. So it's just that the project is kind of compiling everything, bringing everything together, but the assignments are kind of spread out based on what you were taught in that particular week. So if you've been doing well with the assignment, the project will just be a walk in the park for you. You won't really have much challenge as regards that. So yeah, as I also said that I'm also going to be having some persons. I think we'll try to increase the number this time to accommodate more persons doing to do their project defense. So you would be given some time to talk about your project, what you did, how you did it, the insight you got, and just walk through the project, explain everything. Right, is actually very essential. As a data scientist, it's mandatory that you know how to communicate what you've done in your analysis or whatever it is that you did. Right, it's not sufficient. You don't just need to know how to do. Knowing how to do it is a good thing, right? But communicating it is another plus. So whenever you if you look at the skills required for a data scientist or to be a data scientist, they're usually divided into two places: the soft skills and the hard skills, right? So the hard skills are everything we are learning currently, the technical skills and all of that. So, but the soft skills are those things that are transferable, right? Something like communication now is a soft skill, and it's essential you have communication skill as a data scientist because you'll be communicating things, right, to stakeholders, to people that don't even know anything about data at all, right? So that project defense is going to be exposing you to that aspect as well, right? It's a different thing to know something. It's another thing to explain it to somebody. I always say, and I actually believe it, that the best way to learn is actually to teach that thing. That is just the best way to learn. Once you commit yourself to teaching something and you're able to teach it, then you've actually understood that concept. It can be easy for you to assume that you understand this concept, right? Once you are sitting in a class and someone is explaining and all of that, and it makes sense to you, you can actually come to a conclusion that yes, you actually understand this, but you actually not understood it. Once you start um, to explain it, or you put yourself to the task of explaining that thing, you realize that, oh, there are some gaps in my knowledge, right? So the only way you can realize those gaps is actually by explaining that thing to someone else, right? By teaching and communicating it. You get generally communication. So that's what we're going to try to do. By that time, you should have already gotten all the technical skills you need, right? So and then you would come up and then go through what you've done, communicate your findings, communicate the steps, and all of the and all of that. Yeah, so it's part of what we are going to do before we wrap up with the program generally, and then we move on to the next phase. So yeah, that's actually what we have um, um, for the remaining part of this program. Okay, so thank you for sticking with us till this point. All right, so let's go into what we have for today. Let's go into what we have for today. So, but before we proceed, just give me a minute. All right, before we proceed, I'm going to take us through what we did in the last class, like more like a revision, right? To be sure or certain that yes, you are up to speed and up to date, right, with what we've been doing so far. So yesterday we looked at data preprocessing, right? And I've made available the materials in the Google Classroom. Everything is there for you for your perusal, right? And I know I said I was going to send a video material on GitHub. Someone asked about GitHub and how we can upload file. So I actually looked for some resources. I have not seen the resources, a video material that would be suitable yet. So that's why I've not uploaded that or yet. So, but I still have that at the back of my mind. But every other material you need, everything has been made available. So by now you should already have either gone through it or just at least seen the material. So yesterday we looked at data preprocessing. So I told you the importance of data preprocessing in ML, right? That before we have our data for training, we actually need to take it through some steps of preprocessing because the data is coming in a format that is not suitable for to pass it into the algorithm, right? So you have to preprocess it. That is what preprocessing does. And I introduce us to some techniques and to some functions and all of that in sklearn that we can use in preprocessing our data. It was actually a very short class, right? Um, I just wanted to give us some, introduce us to that. So I would just briefly ask some few questions, right? Just to, it's a kind of refresher, right? A kind of refresher. I don't actually expect you to know everything about data preprocessing already because it was what we did yesterday. And I understand that it takes time for some persons to actually assimilate. So if you if you've not gotten comfortable with that yet, it's absolutely fine. All right. It's absolutely fine. But I just want, I believe that by the end of, let's say this week, after you've gone through the material and all of that, you should at least have a good, you should have an idea of what it is and be able to implement what we taught in the last class, right, yourself. Right. But either ways, we are still going to proceed with that. So, yes, this class we looked at data preprocessing. So first off, the first one we looked at how we can handle missing value. So these questions are actually very cheap questions. They're just nothing technical, just like a revision basically. So I introduced a particular technique that is used in handling missing value in sklearn, right? We already know how to handle missing value in pandas, all right? But now, as we saw that sklearn also provide another option for that. So, what is the name of the option provided by sklearn for handling missing values? So I need us to respond to that. So I talked about this yesterday. So what is the name of that particular technique or option provided by sklearn that we can use in handling missing values? I need as many responses as possible. Like I actually need as many responses as possible. I want this to be everybody should participate in this, right? So because one has dropped an answer doesn't mean they are correct. If you still have something else to say, please say it. You might be the one that would get it. Okay, I'm seeing some responses. Impute, imputation, simple imputer. All right. So obviously, based on what we did yesterday, we know that a simple imputer is what we use in handling missing value. All right. Now that we know what we use in handling missing value, how do we import it from sklearn? So I need that particular code that you use in importing simple imputer. How do you import it? Just write it out fully for me. I'm taking note of everybody, trust me. Like I'm taking note of the responses and the names and all of that. So don't feel it's a waste of time um, answering questions here. It's helping you, it's going to help you. And yeah, okay. All right, I'm seeing responses from Kichika, Marcelinos, Anichi, Tijani, Douglas, Ozioma, Musa, Ginika, Patience, Abdul Kafid, Olawale, Olajumoke, Uti Ebunolua, Felicia, Mercy, Confidence. All right, so that is you all actually got it, but I think there's some persons that missed it. So you know that is from input. Input is the particular module that you import simple imputer from. All right. So we use input, right? So you have to get that right. If you don't, if you're some persons are saying from sklearn import simple input, you can try that in your Jupyter notebook to see if it will work. All right, but I assure you it won't work. You have to import it from the input module. Okay, so that is how we import simple imputer. All right, so another question regarding, and the last one for simple imputer. So now what are the different, okay, there's a parameter, right, that you can indicate in why creating a simple imputer instance or object. All right, why instantiating the simple imputer? There's a parameter that you usually indicate, right, to tell the simple imputer that this is the particular method that you use in computing or replacing these missing values. Since you're not going to be dropping the rows, right? I've never landed. I've not landed yet. That's good. That's good. So, yeah. Okay. Some people are saying strategy equals to mean. I do not ask you if it's for numerical variable or categorical variable. Right. Okay. All right. So yeah, that is it. Actually, strategy is a parameter that is usually indicated. Okay. So depending on the data you're working with, you have three. Okay, you have three values that you can pass into this strategy. What are they? There are three values that you can pass into the strategy parameter. What are they? I think let's go deeper. There are three values you can pass into the strategy value parameter. What are they? Sorry, not necessarily three, but five. There are five actually. There are five. Sorry, four, not five. I'm confusing with some other one. There are four. Someone has gotten it. Only one person has gotten it. Only one person. Another person has gotten it. Two persons now. Yeah, yeah. Enari, Nietzsche, Felish, Douglas. Yeah. Ujoma. So yeah, there are actually four values that you can pass into the strategy parameter, which are mean, median, not mode, right? It is not mode, rather we use most frequent, not mode. So it's mean, median, most frequent, and what constant. Okay. So when you, depending on the data you want to handle, if you handle categorical variable, you obviously use the mode, or that, sorry, the most frequent, which is also the same thing as the mode. Okay. But the notation is most frequent. You don't put mode there, else Python will throw an error. Right. So those are the four things, four values that you can pass into the strategy parameter. All right. So that's for simple imputation or simple imputer. Now let's go on to the next one that we looked at yesterday. So we looked at also looked at other methods for handling for encoding our categorical data. So what are the three different techniques of encoding categorical data in sklearn that we looked at yesterday? So quickly, what are those three techniques for encoding categorical data? All right. Okay. Yeah. Yeah. That is it. So we have three of them. We have label encoder, we have ordinal encoder, and we have one hot encoder. Okay. So these are the three techniques we looked at that we can use in encoding our categorical variable. And I told us the essence of encoding our categorical variable. We need to actually convert those string values to what? To numerical value, because the algorithms doesn't take in strings, right? Rather, they take in numbers. So that is why we need to encode it. So you don't just need to know what technique to use, but you need to know why we are actually performing that operation at the first instance. Okay, you need to know why we are actually encoding our data. That is why that is why you're called a data scientist. You need to know why. You need to know the reason why you are doing a particular thing. You don't just do it. Anybody can come and just type in the code and then have it done. But if you don't know why you're doing it, you might find it difficult to fix some errors, or maybe when you didn't get something right, you don't even know what to do. But once you know the reason why, it will be easy for you. Okay, to actually be easy for you. So those are the three methods: label, one hot encoder, and what ordinal encoder. All right, so that is it for that. So we actually need to be able to encode our categorical variables. So yeah, that is it for encoding. Encoding. So we also looked at um, scaling our numerical variables. Now I'm going to ask this first. Why do we scale our numerical variables? Why don't we just leave it like that? Why do we scale? Why do we have to scale our numerical variables? So we just have a few minutes for this particular revision session, and then we'll go into um, the class proper. All right. Okay. Um, page, to standardize it, unique patience to bring the data into the same scale in order for the model to be faster. Yeah, that is nice. That is nice. That is actually a reason for scaling our data miscellaneous to improve performance. Yes. So as to bring our columns to be on the same scale, um, because of different varieties range, so we scale them to improve our model accuracy. Yeah, model performance generally, yeah, from Shamsuddin to improve model performance. Exactly. So, yeah, there's the several reasons why we scale our numerical variables. General one is basically to make our model to train faster, right? If you go into the details of how our model is and what happens during training, we realize that if we have different variables of different scale, it's going to actually be difficult or challenging, or take it to take more time generally for the convergence to happen, because there's what we call back propagation and gradient descent. So those are the things. Those are the Those are what we call optimization algorithm. They are what is used during training. So if your variables are not on the same scale, it's going to pose as an issue, right? So scaling is going to help the algorithm just uh, perform faster, right? And even improve your model performance, all right? And also it helps each of your features or variables to have the same contribute equally to the model in a way, right? So there are a lot of things, right? That there are a lot of reasons why we scale our data, but generally just to make our model to run faster and improve the model performance. Generally, you can check it out. So the in machine learning, the deeper you go, the more you actually realize that yeah, there are a lot of other things to know. Okay, so if you are curious, you can as well go ahead and look at materials that will explain all these things to you. So that's fine. That's fine. I'm actually comfortable with our responses so far. That shows that yes, we are following up with what we've been doing so far. So just to wrap up, what are the two methods for scaling our numerical features? What are the two methods that we mentioned in class for scaling our numerical variables? Two of them. Exactly. I like that response from Olabode. Transforming numerical features to a common scale, and this helps to prevent bias. Exactly. So just make sure that all of them are equal when it comes to um their magnitude, because you can have a particular variable, a numerical variable that is like in millions, right? And you can have another numerical variable that is like in tens. So the magnitude is different. So it's disproportionate. So you need to actually bring them to the same scale. So everything is just equal, right? So there are a lot of reasons why you need to have it at that in that particular format. Okay, so we have two of them. We have standardization. We have min max scalar. Right, we have standards, normalization and standardization. Right, so there are ways to scale our data. We have for standardization, we use standard scalar. For normalization, we use what min max scalar. Right, so there's a particular there's one of these that requires your data to be normally distributed. Which of them requires that? Have that as a criteria before you use it. Everybody say normalization. Is it because normalization has normal in its name? Oh, okay. I'm waiting for more responses. I'm waiting for more responses. We have 54 persons on this call, and I don't think I've had up to 20 responses at a time. It's just the same set of people that have been responding. Okay, okay. Because of time, only one person got it here, and that is Kelvin. Right. So the particular technique that requires the data to be normally distributed is standardization. That is using standard scalar. Right, so normalization doesn't have that assumption. You can perform min-max scalar on any kind of the data, regardless of the distribution. I mentioned this in yesterday's class. I remember I mentioned it in yesterday's class. Standardization requires your data to be what normally distributed. Okay, so that's it. So that is it. So we've actually just gone over what we did yesterday. I believe with this, you should either be challenged to go back to the materials, right, and you should be challenged to go back to the material. Okay, if you are not, if you actually didn't follow up with, or you are lost in this particular revision session, so go back to the class recording and the material to help you um understand everything that we've just said now. Min-max scalar doesn't have the assumption. Shamsuddin, it's standard scalar. Min-max scalar can work on any kind of data regardless of the distribution. Right? So, okay, that's it for that. Let's go straight to this class. So yeah, before I forget, so I gave you all assignments last week. Give us assignment last week. I'm looking at doing the correction. Well, still, I'm also looking at time as well. Well, at this point, I feel we should be able to correct ourselves, right? Because this is something that we've done over and over again. If you go back to the classes that we had, all of these things were already explained there, right? What I gave us in the last assignment was actually kind of more challenging than the previous assignment. We remember that in the past few weeks, we've actually not had enough coding assignment. We've just been doing normal theoretical and all of those kind of essay where you have to write out your answers. But now we had an assignment that requires or involves writing code. So it was just to test you on all the algorithms that we've learned so far on KNN, on decision tree, random forest, and all of those algorithms that we looked at. So, well, let me quickly go over it. I think it's necessary. I'm just going to use like let's say 5 to 7 minutes for that. Okay. I'll be sharing my screen now. All right. So hope everyone can see my screen. Hope everyone can see my screen. All right. So now I picked up this assignment from your class rep, that's Mohammed. I love this assignment. I'll have to say that. So although I've not graded everything yet, so I've not seen every assignment, but I'm just use this one for correction. Okay. So this is the instruction, so I don't need to go over that again. Now, first question. Using the breast cancer dataset provided by SKLN. So I didn't give you any dataset to download. You just need to get everything from SKLN yourself. We've looked at how we can do that. So the dataset you need to get, I gave you the code here. SKLN dataset, load breast cancer. Just you know how to set everything up right. So the question is right, I have three of them here. Implement a K nearest neighbor classifier to predict the tumor class. So this is very straightforward. You know how to use the K nearest neighbor, how to import it, how to instantiate it, and all of that. We have this second one here, which requires you to experiment with different values of K. Now, today, we are looking at hyperparameter tuning. So this is going to make more sense to you when we look at this parameters today. But basically, you just have to know how to use this particular parameter here by changing it. So you can create a model, put a particular value, you train it and use it for prediction, and you get an accuracy and all of that. You can also train another model and use a different value of k, and you check if the performance is better or not. So that's just what you had to do here, you were asked to do here. So how does changing k affect the model's accuracy? So it's left for you to know what the based on the results you got. So the third question is just for you to discuss the pros and cons of using KNN for this classification. So this particular question, it should push you to go online to read more about KNN. Okay, even if you don't necessarily need to know the answer to this from the top of your head. Okay, so you can go online to check and just get answer. The main thing is for you to understand what you are writing. Okay, it pushes you to learn. That is the aim of assignment. Right, assignment, if it doesn't assume that you already know it. So yeah, let's just proceed. That's the first one. So I will not really go over the implementation too much. So you can see where this he imported all the necessary the libraries here and all the things, data set and all of that you need for your model building. Okay, so we have this. You now have to load your data set and all of that, and then you split, you initialize, you classifier. So the first thing is to initialize with what was the answer here? Experiment with different level. Okay, I didn't specify, so you can initialize with any value of any neighbors. All right, so you then train it and then get your accuracy. So you can see the first accuracy is 0.96 for k is equals to 5. All right, so you can try it again on another one. So n neighbors equals to 7. So you try it and you see, okay, it gives you the same accuracy. All right, so yeah, that is, you can see that it didn't really change. The accuracy didn't really change much. So it shows you that whether you increase it by 7, but you can try other values as well to see if it is going to actually affect the accuracy. So that is just it. That is just it. So you can quickly check out. Okay. Okay, I think the first one here should be 0.94. But anyways, let's not just go into that. So that is it for the first question. The second question, you have to use the wine data set. Right, there's a particular data set, load wine data set. It is used, it's a classification task basically. So in this question, I asked you to implement a support vector machine classifier with a linear kernel and evaluate its performance on the wine classification. Remember, I explained what this kernel mean, right? What does kernel mean in SVM, if you can remember clearly. All right, let me see if we can see if we remember. Can someone just let us know what a kernel is in SVM? Anybody? What is a kernel? I just need one person to just answer this. Let me see if you can still remember. All right, so as you are still typing, let's go over the other question. So, second question was use a non-linear kernel, e.g. RBF kernel, and compare the performance with the linear kernel, and then explain the concept of kernel trick and why it is useful in SVM. See, like if you did this, or if you did all this assignment, like if you actually took your time to do all this assignment, you would learn a lot, right? It will actually learn a lot. So it's not for me, it's for you. All right. yeah, you definitely get grades and all of that, but you would also learn, right? There's some things that we may not talk about exhaustively in class, but when you look at this assignment and you go and make your own research, watch videos to understand some things better. I know we have limited time, but still yet you can just take out a few minutes and do all these things. You would actually get to know some things, right, that we was not even said in class. All right, so these are the advantages. These are the things that you can do to just keep yourself above average, right? So I talked about kernel in the last in SVM class. Basically, what I said is that kernel kernel trick is used when our data is not linearly separable. Right? When we cannot use a line to separate our data, we use kernel. So kernel actually take our data from a lower dimension to a higher dimension, and then you can now like create an hyperplane in that higher dimension. So you can actually use the kernel to separate two classes that are not linearly separable. That is basically what a kernel is. All right. So a linear kernel here is basically just the normal kernel that you use in separating the linear a data set that is linearly separable. That's why I call it linear kernel. But we have other kernels like RBF kernel. So this one they can be adapted, right, to any kind of data that you have that are not actually linearly separable. So those are just what kernels mean in SVM. So we can see we'll go over the importing and all of that, the data loading, splitting, and all those things. So you can see we initialize the kernel here linear, and then you get your accuracy, and then you use a non-linear to you get your so these are just what I expected from you. So the next question here is using the same thing but on decision tree. So because of time, I don't really want to go into details on the assignment, but if you didn't get the assignment, please still take your time to go do it. All right. For this particular assignment, I will still give you, if let's say you had a reason why you're unable to complete it, please, I'll give you grace. I'll still give you grace because it's looking at the assignment is actually bulky, right? So I've actually not graded yet, so you can as well, um, if you've done it or not that you've not done it and you are looking to do. If you've done and you've not submitted yet, so you can just come to me with valid reasons actually. Because other people that did it don't. They also have things that they are doing. But if you have a very valid excuse and reason for not completing this assignment, then all right, just come to me them. So the same pattern is seen across the other questions. So just picking each of the algorithm and just giving you some questions to look at. Okay, so there was something I saw in this particular assignment that captured my attention. So you can see we have something here. This is a decision tree, and we didn't even do this in class. Like, just kudos to Mohammed for doing this. We didn't do this in class, but he was able to represent the decision tree model in a graph form, right? So this was what we're trying to explain. So this is the splitting that happens. This is what happens, okay? So to achieve this, you can see that there is a particular function that he imported from sklearn tree module. So and that function can be used to plot the decision tree model. So this is what is being used in making the decision. Okay, so that's another good thing of learning extra things and just experimenting and researching and all of that. So you get to learn a lot. Machine learning, data science is wide. Like, even as I am now, there are things I even see and that are new to me, like a lot of times. So if you restrict yourself to just what someone is teaching you, you would actually not be able to expand. You would not actually not be able to adapt and be flexible, because there are some situations you come in, they'll bring in some concept or they're required to know some concept, and you'll be like, you've never heard of this before. So if you're able to like just put yourself out there constantly, you'll be picking up a lot of things, and the chances of you being very good and adapting and being flexible to work in any environment will be very high. All right. So we didn't promise to teach you every single thing, which is not even possible. Nobody can teach you every single thing. Okay, so I'm just advising and encouraging you to do that, and try as much as you can, right, to be a self learner. That's how you grow. All right, so that's it for the assignment. We would not want to waste much time on that. So if you need explanation on some of these things, you can ask to Mohammed, the class rep, and I believe we'll be able to. He will be kind enough to explain them to you. All right, so let's go to today's topic. All right, so today we're going to be looking at hyperparameter tuning, or rather, improving model performance. All right, we're going to look at how to improve model performance. So there's some key concepts we're going to learn. See, since we started machine learning, I believe every day you are always getting to learn new things. Every day you're always getting to learn new things, and that is how it's going to be. So you should just be able to, you should set your mind that, these are the things that you might not necessarily know them, but the same way you've learned other things, the same way you learn them. So they are actually not complex at all, right? They're not complex. So that is why you need to have understood the previous things we've done before. If you've not, this one will be difficult to understand. The subsequent ones will not be as easy as you, as it seems, as you think it is, right? As you expect it to be. So that's just the idea behind learning. You need to understand the things that precede what it is that you want to learn now. So today we're going to look at hyperparameter tuning, how to improve our model performance. If you don't know how to create a model, then how would you be able to improve its performance? So you have to know how to create a model first, how to use algorithm and all of that, all of those things. So it's assumed that you're comfortable with all of that. So today we're going to look at improving our model performance. So before now, you've been hearing of overfitting, and all of that. And I told you that we are going to look at overfitting, right? I think in last week class, I told you. So today we're going to actually look at what overfitting is. We're going to look at what overfitting is and how to handle it. But before we proceed, just know that overfitting what is a bad thing. Overfitting is a bad thing, and we are trying to prevent it in ML, in machine learning. We are always trying to prevent it. It is one of the things that we try to prevent. Okay, so let's move on. Now, these are the things we're going to look at. We're going to look at overfitting and underfitting. We're going to look at bias and variance. We're going to look at hyperparameter tuning. We're going to look at GridSearch and RandomizedSearch. I believe I hope we're able to do all this under 1 hour, because we have 1 hour to go, and I won't want to keep us longer than that, because I believe we all have things to do, and we've actually scheduled our time. All right, so please, before we proceed, let me know in the group if we can still hear me loud and clear. I need more responses. I actually need I want to see new persons like responding this time. I believe there's some persons here that have never said anything in this group. Never, never. They're just there observing everything that is going on. All right, okay. Let's just move on. We don't really have much time. All right, what exactly is overfitting? What exactly is overfitting? Please pay attention. I pay attention, right? Because there are some technical things that will be said, some technical things will be used in explaining this. So overfitting occurs when a model learns the details and noise in the training data to the extent that it negatively impacts the performance of the model on new data. What does it mean? It means that the model will perform very well on the training data, but poorly on the testing data. Let me explain this. Remember that what we are trying to do in ML, we are trying to actually train our model on a data and a data set, and then use the knowledge that we've gotten from that training to make prediction on another new data, right? Similar data, of course, but on another data that was not seen during training. That's the whole idea behind machine learning, all right? But now there's something that can actually happen that is bad. If we train, or if our model learns too much details, okay, it learns too much details and irrelevant information or irrelevant info from the training data, it would now basically not be able to make good predictions on the test data because it has basically overfit on the training data set. Let me try to use an example, right? Let's say you want to prepare for an exam. You want to write a test, right, on a particular subject. And you are given you have a textbook, right? You have a textbook that you are supposed to use to prepare for that particular test. What are you supposed to do in that textbook? You're supposed to look at the topics that you are look at the topics generally that you've been taught, okay, and all of that. So you have to have a general overview, a general idea of all the topics and all of that before moving on to take your test. But now, instead of you to kind of look at those important information in the textbook, right, that is required of you to know so as to answer questions that will likely come out in the test, you now start to read irrelevant information in the textbook, like things that are not necessarily going to be seen during the tests. Do you understand? So I can't really give example a specific example, but that is the idea here. Like in a textbook, it is not every single thing that you need to know or that is going to be relevant, right? So when you now start paying much attention to every single detail and both irrelevant details and relevant details and noise, you are now overfitting. That's basically what overfitting is. So when you come on the test day and you want to write your test, what you've already read, you focus too much on irrelevant data or irrelevant details in the textbook, that when they give you a particular question, now begin to look at the question. I don't really know this answer, or I don't really know this answer, because you didn't actually pay attention to the general idea in the textbook. You didn't pay attention to those things that are commonly going to be asked or commonly going to be seen. All right. So that is what overfitting is. So when we have a model paying too much attention to details and noise in the training data set, we have actually overfit that model, and the performance is going to be bad, right? Because it will not be able to generalize on unseen new data. So you don't want it to learn too much, and you don't also want it to learn too little. That is the idea. You don't want your model to learn too much, and you don't want it to learn too little. You just want it to learn enough to be able to generalize, to be able to make predictions, very good predictions, right? Because you are trying to what? You are trying to the essence of training on a data set is trying to build a model. What does a model mean? A model in its real sense is what? A representation of something. So when you build a model, you build a representation of a particular thing. So that representation has to be a good representation. So when you now use that model in making predictions on that thing that it represents, similar data point, it should be able to make a very good prediction because it has built a good representation, a good representation or a good model. All right. But when you've actually, or when the model overfits, you've actually focused so much. You focus so much on only that training data that you've not captured the representation well, right? And then it begins to perform poorly on same data or new data set that you introduce to it. So that is the problem of overfitting. It's actually a problem that you can come across when training your machine learning model, and it's fine if if it happens, right? There are some things that you would see, or yeah, we're going to look at how you know if your model is overfitting or not. All right. So we also have the other one, which we're going to look at, which is underfitting as well. So they're actually just two sides of a coin. So we have overfitting and we have underfitting. Right. We don't want our model to overfit, and we also don't want our model to underfit. So what are the things that you would see that will make you know that, okay, my model is actually overfitting? First off is what? High accuracy on training data sets. So if you train your data, or if you train your model on a particular data, on your training data set, remember that since we've been actually training our model, we've actually not evaluated our model using what? The trained data set. Like if you remember, we've actually not evaluated our model on the training data set. Okay, we've only evaluated it on the test data set, right? So a way to know if your model is overfitting is by checking first the accuracy on the training data by predicting the training data again. That data you trained your model on, you now try to use that model to make predictions. So if the accuracy is high, right, it's not a bad thing. Like, it's not actually a bad thing for the accuracy to be very high, because you don't just use that single metric to conclude that your model has overfit. You keep it one side. Okay, my accuracy on training data set is high. Okay, now let's see my accuracy on the test data set, right? On the new data set, right? The data set that was kept aside, that was not used in training. So when you now evaluate that model on your test data set and the accuracy is low, then there's a problem. That's when you say, aha, this my model has overfit on the training data set, right? Because it knows too much from the training data set, but now when it comes to another new data set, it doesn't know too much again. The accuracy is low. So what does that tell you? It tells you that you have overfit your model on your training data sets. Do you understand? That's exactly what it means. So there are so many things that can cause overfitting. All right, we're going to just look at three of them. So the first one is what? Too complex model. You might not necessarily come across too complex model in this traditional ML that we're doing. All right, maybe when you're working with neural networks, and then you can actually now start seeing very complex architecture and all of that. But then there are some particular tasks that will require just very simple model, like KNN, very simple model. But now you now go and start using XGBoost. XGBoost, that is like your patapata of all the model for classification. You're not going to use it on one very simple classification task. No, it's going to overfit, right? That is a cause of overfitting. So those are one of the cause of overfitting, but you cannot conclude. Then you have to train your model and see the accuracy and just conclude. That is when you can actually make very substantial and come to a tangible conclusion that, okay, my model has overfit. So the second one is what? Insufficient training data. So when you don't have so many data, you might run the risk of overfitting your model on your data. Okay. So how do you come to the conclusion the accuracy of test data set is low? I don't. It's straightforward. If you have an accuracy of 0.64 from your test data set, it's obviously low because the highest accuracy you can get is what 100% or 1. All right. So once you have that your accuracy 0.65, let's assume for your training data set you have an accuracy of 0.96 for your training data set too. You now evaluate it again on your test data set. You now realize that your test data set accuracy was 0.64. You can see the gap. You can see that the accuracy is high on the training data set and low on the test data set. So you can conclude that your model has overfit. All right. So the other cause here is insufficient training data. So if you don't have plenty data, you can run the risk of overfitting. So so that's another cause. The another one is excessive training time. So if you spend so much time training your data, there are some algorithms that you can keep on training, model that you can keep on training. So you actually specify a stop, right? So, but if you train so much, if you allow it to run through so many iterations or epochs, you might actually run the risk of overfitting because it will learn too much from your data. So excessive training time can also be another problem. So now that we've understood what overfitting is and the cause and all of that, so how can we actually solve it? What's the solution? So we have 4 of them here, or we have 3 of them here, like that is most common. So the first one is simplifying the model. So now another thing that can actually make your model complex is not just the algorithm you're using. The complexity can also be as a result of the parameters that you have, right? If you indicate too many parameters in your model, right, it can lead to your model being complex. You already understand what parameters are, right? So if to reduce the overfitting, you can remove some of the parameters that you've indicated, so as to just reduce the complexity, to simplify the model. That is one solution. Another solution is to collect more training data sets. That is obviously self-explanatory. And also use regularization techniques. So we're going to look at regularization techniques in next class. I think it should be Saturday or Sunday. So regularization techniques, there are also methods of dealing with overfitting. All right. So we have employing cross-validation to monitor model performance. So this is also another one, but these first 3 are the most common. Okay. So now you can see this diagram here. This diagram shows us what overfitting looks like. So remember linear regression. What does linear regression do? It's what draws a straight line, right, that minimize the sums of square error. Okay. Now imagine that this is now the line you are getting, right? Every dot is being connected. There's something called polynomial regression. Actually, polynomial regression is an adaptation of linear regression that allows you to kind of introduce curves to that line, to the linear regression line, so you can actually fit your data more. So when you have this kind of model, you know that your model is overfitting. Like, it's actually overfitting. It is mapping. It is learning too much detail, right, from the data set that you're using to train it. So this is a kind of overfitting. This is an example of overfitting. So we should have something like this. You should just have maybe a straight line coming like this, or maybe just a little curve that might kind of just shift to just fit in the data well. All right, so this is just an illustration of overfitting. So let's look at underfitting. So if you understand overfitting, you should understand if you understand overfitting, you should understand underfitting. Underfitting is the opposite. So underfitting occurs when a model is too simple. Remember, I told you that you don't want to learn too much, and you also don't want to learn too little. Do you understand? So when your model learn too much, you what you when your model learn too much, you overfit. When your model learn too little, what you underfit. Right? That is basically what underfitting is. Okay, so I'm just trying to I'm trying to remember a particular example that I might use. That's why I'm pausing here and slowing down a little. So I need you to understand this very, very well. Mm. Okay, let's just move on. Let's just move on. Once I remember, I'm going to the top here. So, underfitting occurs when a model is too simple to capture the underlying patterns in a data. So, the same opposite of overfitting, which results in poor performance on both the training and the test. So, this one is even worse. The data will be, or the accuracy on the training data set will be poor, and the accuracy on the testing data set will also be what poor. That is the indication of underfit. So underfitting is actually rare. It's not as common as overfit. That is why you always see overfitting everywhere. Underfitting is rare, all right, as compared to overfitting. So how do you know your model is underfitting? When your accuracy is low on both the training and the test data, all right. What are the causes? Too simple model and insufficient training time. So everything that you've learned about underfitting, they just flip it to the other side and it is underfitting. Solution: increase model complexity, train for a longer period, use more relevant features. So you can see this particular now. This other one that we have here, it's actually overfits the data, and this one kind of underfits the data. So it's not learning enough, right? So this is just an illustration, a diagram to show you exactly what that is. So we're going to look at another two very important concepts: bias and variance. So bias and variance, they're tightly related to underfitting and overfitting. All right, so let me be sure. I hope everyone can still hear me and you're still following. All right. Okay. So let's just quickly go over this. So bias and variance, they are very important concepts in ML, and they are related, very, very tightly related to underfitting and overfitting. So what does bias mean? Bias is just the error. Bias is the same thing as error, right? When you have low accuracy, you have what? High bias. That is just it. Like there is no other explanation. When you have low accuracy, you have high bias. When you have high accuracy, you have low bias. So bias is basically the error, right? The error, or that thing, that particular error that is introduced. So by approximating to a reward problem, right? That is when you're trying to use a model in a reward problem. So high bias can lead to what? Underfitting, obviously. When you have high, let's assume you train your data on a training data set, and you what evaluate your model on that same training data set, and you what have an accuracy of what? Let's say 0.60. That is what we call high bias. We have a high bias, meaning high error, and it's almost the same thing as underfitting. All right, so they are very, very closely related. Okay, so we have this here, so you can see high bias lead to underfitting. Characteristics: assumptions made by the model are too strong. Model is too rigid to learn from the data. So if you understood underfitting, you should understand what bias is. So these are very, very, very closely related. So let's look at variance. So variance and bias, they are usually used together. So whenever you hear variance, you always hear bias. So what does variance mean? Variance is literally the difference you would get when you compute the accuracy on your training data and you compute the accuracy on your test data. If the difference is high, then you have high variance. If the difference is low, that means you have low variance. The example I gave before of overfitting, where you have your accuracy on your training data to be 0.96 and then your accuracy on your test data to be 0.64, is the difference in accuracy high or low? Let me get the response. This instance I just gave now, is the difference in accuracy high or low? I said that, for instance, if you train a model and then you evaluate it on the training data set and the accuracy is 0.96, then you come and evaluate that model on a new data set, test data set, and the accuracy is 0.64. Is the difference in accuracy high or low? Exactly. The difference is high. All right. So that difference, that high difference, is what we call that is variance. Is literally it's like the difference in something. Okay. So when the difference is high, then we have high variance. When the difference is low, we have low variance. So these are just terminologies I'm introducing to you. Okay. These are just terminologies that you need to get comfortable with. So if you have, let's say, a model that has an accuracy on the training data set to be 0.75 and then has an accuracy on the test data set to be 0.69 or 0.71. Okay, let's say accuracy on training data set is 0.75, accuracy on test data set is 0.7y. Is the variance high or low? In this particular case, is the variance high or low? Exactly. Exactly. That is the idea behind it. So that is what variance is, and that is what bias is. All right. So these are the things that you actually use or you pay attention to when you're evaluating your model. So they are tightly knit with underfitting and overfitting. All right. So let's just proceed from this. I think we've all gotten the idea. Right. So there's what we call bias variance trade-off. Okay, bias, variance, trade-off. So the trade-off is a key challenge in machine learning, right? A model with low bias might have high variance and vice versa. Let me go back to this and just. So there are several possibilities or several combination of bias and variance. So we can have a model can have what? High bias and high variance. Let me make this to be one. High bias and high variance. The model can have high bias and what? Low variance. Model can have what? Low bias and low variance. Model can also have what? Low bias and high variance. So these are the different combinations. So if you create a model, just know that your model should fall in any of these category here. Understand? So if your model can fall in any of these categories. So for instance, let's say I'm going to use training. I'm going to use A for training and then B for test. So let's say the accuracy for your training is what? 0.65. And then your accuracy for, okay, let me just use train and test. Train and test. Let's use what? 7.5 here. Seven one, and your test accuracy is 0.60. All right. Let me come here. High bias train is what? 0.71, and then test is what? 0.68. Low bias and low variance train is what? 0.95. This is what? 0. Let's say 92. And then we have low bias and high variance. We have 0. Train is equals to 0. Let's say 95, right? And then test equals to 0. Let's say 70. So this is exactly how you can have bias and variance combined. So whenever you create a model, you should automatically know which of this combination your model fall under. If your training data set have an accuracy of 71% and your test has an accuracy of, let's say, 60, then you know that your both of them, there's high bias and high variance. And then the ideal position you want to be in is what? Low bias and what? Low variance. So this is the ideal position here. Do you understand? So out of all this, which of this particular combination is overfitting? I want you to look at it, and based on what we've talked, which of this combination is overfitting? You can just say 1, 2, 3, or 4. Anyone. 1, 2, 3, and 4. Only one person has gotten it. All right. Michael Wanaga, you got it. You said 4. Ebunoluwa, you said 4. Yeah. So 4 is the particular combination that shows overfitting. What did we say overfitting is again? Overfitting is when your model learns too much from your trained data. So when you see, let's go back to this here. Hyperparameter tuning. What did we say are the symptoms? High accuracy on training data and what? Low accuracy on testing data. So now we come here. High accuracy, this is training data, high accuracy. The accuracy is what? 95%. Then we have low accuracy on test data, which is 70%. Okay. So this particular model, if your model falls here, just know your model is overfitting. Now you should find a way to reduce the overfitting so that at least the test data accuracy can be improved. So you don't want this one. You don't want this particular one, high bias and high variance at all. You want to avoid it by all means. You also want to avoid this one, high bias and low variance. Then this one is what you want, low bias and low variance. This is the ideal position you want your model to be in. Okay, this is where you want your model to be in, this combination here. So that's just it about bias variance trade-off. All right, that is what we are trying to look at here. So
The goal here is to find the right balance where both bias and variance are minimized to achieve the best generalization performance on unseen data. All right. So you want to make sure that you minimize the bias and variance, right? So that is just what it is in or what we are trying to do in bias variance trade-off. So all these things are concepts that you can be applying to when training your machine learning model. So I believe we all understand that now. We understand what overfitting is, and we understand how to tackle it, how to know if our model is overfitting or not, and all of that. So now we're going to go to the next phase of this class, which is called hyperparameter tuning. Hyperparameter tuning. So now we want to be able to like get the best model performance, right? So we can do it manually. I gave you an assignment where I asked you to check or try KNN on different values of what? Of K, okay? And see which one has the best performance. So that is basically an example of tuning your hyperparameter, right? So all those things that we have looked at, all those algorithms and all those parameters that we've looked at for these different algorithms, they are called hyperparameter. And we want to tune them. Tuning basically just means adjusting the values of each of them, changing the different values to see if it will improve the performance or not. Remember the TV we had back in the days, those black and white TV that you have to turn a particular knob by the side to get a very good reception, that kind of thing. So that is exactly the same thing that happens in tuning. You're trying to tune the knob to a position that you are to get the clearest reception possible. So the same thing happens here in hyperparameter tuning. Just imagine that the same knob. We are trying to tune the hyperparameters so as to get the best accuracy possible. Do you understand? That's why they call it hyperparameter tuning. So let's just move ahead. Let's move ahead. So hyperparameter tuning is the process of optimizing the hyperparameters of a machine learning model to improve its performance. Okay? So what are hyperparameters? Hyperparameters are parameters that are not learned from the data but set before the learning process begins, e.g., learning rate, number of trees in the forest, and n neighbors, all those things, like any model that you are, any algorithm you are using, all those parameters that you have there, they are called hyperparameters. And you want to be able to tune them to get the best performance. So there are different approaches. There are actually ways we can do this thing in sklearn, and we're going to look at it. Okay. So the first one approach is what? Manual search. Manual search is the first thing you would think of if you don't know how to use hyperparameter tuning techniques. You would have to just be building different models with different hyperparameters and then be comparing their results. So it is very long, lengthy, rigorous, and just disorganized, right? You can actually do it that way, and you realize that it's time consuming and actually not very efficient. So there's another approach which is called automated search. All right, automated search. So this is what we're going to be looking at today. So sklearn provides these two different automated search that is used to actually automatically search through our hyperparameters and get the best combination that will give us the best accuracy. So all this thing will be done for you automatically in sklearn. We're going to see it in action very soon. So the two methods under automated search are GridSearch and RandomizedSearch. GridSearch and what? RandomizedSearch. So I look at both of them quickly. So, but before we look at GridSearch and RandomizedSearch, we have to look at what we call cross-validation, because GridSearch and RandomizedSearch, they use cross-validation technique in searching through the hyperparameters, right? So we are going to look at all these things. So see, data science is a lot. Like, you need to understand all these things. Very important. You need to understand what they do. So now quickly, what is cross-validation? Cross-validation is a technique used in machine learning to evaluate the model's performance and ensure its ability to generalize to independent data sets. It involves partitioning the data set into subsets, training the model on some subset, and validating it on the remaining subset. This process is repeated multiple times and result are average to provide a robust estimate of the model performance. So there was someone that asked this question the other time when we were doing ensemble learning. Asked if cross-validation can be classified as ensemble learning technique, and I said no, because ensemble learning has other things that makes it ensemble learning, other processes, right? But it's actually similar to cross-validation. So cross-validation is a separate technique on its own that GridSearch and RandomizedSearch utilizes in doing what it does or what they do. Okay, so now let me just scroll down to this diagram here because it would help you understand it better. So this is basically what cross-validation is. Okay, this is basically what cross-validation. Yeah, Shamsuddin, I think you were the one that asked that question. So this is the cross-validation here. So what happens during cross-validation? Now is imagine you have a data set of 1,000 rows, 1,000 observations. What will you do normally when you want to build your machine learning model using the normal method? You will just import your data, split it into X and Y, and then split the X and Y into training what data set and test data set. And then you train on the training data set, and then you evaluate on the test data set. That is the simple way. But cross-validation is quite different. What cross-validation does is that it actually uses every part of your data set as both training and testing. So this is what it does. First of all, it partitions your data set, let's say, depending on the number of k-fold or number of partition you indicate. Okay, so let's say in this case we indicate that it should be 5. All right, so to partition your data set into 5 places. So now you have 200, 200, 200, 200, 200 into 5. Now what it will now do is that it will now use the first 200 as the test, and then use the remaining 200, that is 800 altogether, for training. So when it trains on this 800 data set, it will now evaluate on this 200 and then give you your accuracy. That is the first experiment. That is the first model, right? It now comes again and use the second partition as the test and use the remaining part of data as the training. So it trains on this order data set and then evaluate on this 200 data set and give you accuracy. So it does the same thing for each of the partition and give you accuracy for each of them. So the idea here is that it wants to try to touch every part of the data set. That is what cross-validation tries to do. That is cross-validation. It is validating the data set with itself. All right. So when you get the accuracy for each of these data experiments, then get the average of the this thing, and then give you the final accuracy metric. So this is what happens during cross-validation. So all these other things here, they are just explanation and all of that. So if you can see here how cross-validation works, it first splits the data. The data set is divided into k subset of folds. So you can see here you have to choose if you want to do it manually, because you can actually implement k validation manually in SQL. But the reason why we are looking at cross-validation is because GridSearch and RandomizedSearch uses cross-validation. So I just want you to understand it. So you split your set, and then you can now see that the model is trained k times, each using k minus 1 fold for training and the remaining fold for validation. All right, so all those things I explained is exactly the same thing here, right? So after k iteration, you have k performance metric. That's like maybe after 5 iterations, you have 5 accuracies. So these metrics are averaged to give a single estimate of the model's performance, providing a more reliable measure of the model's ability to generalize to unseen data. All right. So these are the benefits of cross-validation, right? It's also helping them detecting overfitting, right? And other things that we have here. So let's quickly look at GridSearch and RandomizedSearch. So what is GridSearch? What is GridSearch? GridSearch and RandomizedSearch are the same thing. Okay, it's just that RandomizedSearch takes a different approach, right? While GridSearch takes a different approach. And we're going to understand that. So there's a diagram here. I guess we're going to use it to explain. But let's quickly build your intuition on GridSearch and RandomizedSearch. So what is GridSearch? GridSearch is a systematic approach to hyperparameter tuning, where a model is evaluated for each combination of hyperparameters in a specified grid. So one of the thing about this kind of topics is that they are usually abstract, but we'll definitely implement them in code. So let me come here and say GridSearch. All right. So don't worry if you not completely grasp it now. We are going to show you how we can do it in code, so you would understand it by then. So, but just follow me here. So you remember I asked what hyperparameters are, right? Okay, I've told you that hyperparameters are those parameters that you can actually set before you train your model. You can change the values and all of those things. So GridSearch helps you to look at different combinations of hyperparameters and then give you those combinations that will give you the best accuracy. So you don't need to come and be testing your model on different values of k, of n neighbors. You want to try, okay, let's assume that you want to try like you want to build a KNN model on k is equals to 3, k is equals to 4, k is equals to 5, k is equals to 6, and k is equals to 7. So normally what you do is that you train different models. You train 1, 2, 3, 4, 5 models using different keys. Do you understand? So that is how you do it manually. But in GridSearch will help you to do these things without going through that stress. You just have to indicate the different values, and we are going to see how to do it. So let's now assume that you don't just want to use one parameter. You want to use n neighbor, and you also want to use, let's say, another parameter as well. So now you can now see that you now have to combine maybe n is equals to 3 with, let's say, another parameter value. N is equals to 3 with the second value of that hyperparameter. So you can now see that there's going to be a lot of combinations. So if you're going to train a model with 2 hyperparameters, let's say each having their own different set of values, you're going to have to train like 20 models, or let's say even 100 models sometimes, and then look at the accuracy of each of those models and pick the best, which is going to be very time consuming. But GridSearch would help you do it efficiently. All you just need to do is just to indicate the values for each of those hyperparameters, and then it will go through all the combination and look at the accuracy, right, using cross-validation. And then at the end, you're going to get what? The best combination that gives the best performance, right? So the process, so it defines a grid of hyperparameters. So you have to specify what we call param grid, right? And then you train and evaluate the model for each combination. That is what it does. You will not do this one yourself. And then it will select the combination with the best performance. So the same thing happens for random search too. But the difference is that for GridSearch, it actually goes through every single combination. If there are 1,000 combinations, it will go through every single one of them, one after the other, and then look at the accuracy of all of them and pick that combination that has the best accuracy. And then you can now use it to now train your model. Okay. why randomized search? Randomized search doesn't go through every single thing. It just randomly picks the different combinations. So the disadvantage of randomized search is that it might not pick the best accuracy score, right? But and the advantage is that it is more efficient because it's faster. You don't have to go through all. You can see the diagram here. This is grid search. This is what randomized search, and you can see that we have two hyperparameters. Yeah, let's say this is a random forest model, and we have max depth and we have n estimators here. So it would now go through each combination of these the different values for each of these parameters. And you can see at the end, it selected this one here, this green bubble, as the best combination that give the best result. Why for randomized search, you can see that it's actually random. It didn't go through every single combination. It just, like, let's say random, it went through, like, let's say 20 random combinations, and out of those 20 random combinations, the one with the highest accuracy or best score is now selected. So grid search advantage is that it guarantees the best result, but it is time consuming. It is computationally expensive because if there is 1 million combinations, it will go through those 1 million combinations and it will take a lot of time. But randomized search, if there's 1 million combination, you can only go through, like, let's say 100 or 200 of them and then get the accuracy. So that is what happens in these two techniques. Okay. So you can see the disadvantage of random grid search. It is computationally expensive and time consuming, and it's also inefficient for large hyperparameter spaces. So there's some hyperparameters, there's some algorithm that will have, like, let's say 5 hyperparameters, and combination in mathematics now, it is an exponential operation, right? So you can have like 10 million combinations of hyperparameters. So, or depending on the number of values that you have. So we are going to demonstrate it. Don't worry, you'll see exactly how it works. So for randomized search, let's just quickly go over it. A randomized search is an approach to hyperparameter where a model is evaluated for a fixed number of random combinations of hyperparameters from a specified range. So from a fixed number of random combinations. So you would specify the number of random combinations here. So the process that it defines a range for each hyperparameter. You now randomly sample a fixed number of combinations from the range, and then train and evaluate the model for each combination. So, and then give you the combination with the best performance. So this is just the process, and almost the same with grid search. So what are the differences between grid search and randomized search? So in grid search, we try every combination of a preset list of values of hyperparameters and choose the best combination based on the cross-validation score. All right. The second one is the randomized search tries random combination of range of values. So we have to actually tell it how many iterations or how many random sample it is going to use. Very important in randomized search. It is good at testing a wide range of values, and normally it reaches a very good combination very fast. But the problem is that it doesn't guarantee to give the best parameter combination because it is not exhaustive. It did not go all through it did not go through all the combinations, right? So, but it's obviously going to give you a good accuracy, but not necessarily the best. Right, so you have to know which one to use. If you have a lot of hyperparameters, just go for randomized search. If your hyperparameters are not plenty, go for grid search. So grid search will give you the best combination, but it can take a lot of time. So now let's look at how we can implement it in sklearn. All right, so we're going to see how we can use randomized search and GridSearchCV in selecting best hyperparameters. So for this particular one, we're going to use random forest classifier. So let's import that. So from sklearn dot ensemble import random forest. Why is this not completing forest? All right, so we also have to import the GridSearch model selection. Import GridSearchCV. So you see this CV here means what? Like, can someone just type it in the group chat? What does this CV here means? Exactly. That is exactly why I needed to explain that cross-validation initially, so you understand that that is what is being used in GridSearchCV and RandomizedSearchCV. All right. So we import GridSearchCV. So let's use the data set that we're going to use now. What data set? Load iris. And let's just use the breast cancer data set that we've been using all this while. Set import load. All right. So what do we have to import again? Okay. Train scaling dot. Okay, so we imported the necessary libraries. Let's just go ahead. Let's create our x is equals to data is equals to load, and then come here and say x is equals to data, y is equals to data dot target. All right, so we've loaded our data set. Let me come and say loading the data set. So the next thing is just splitting our data set. So we will not spend so much time, because what we want to do is just demonstrate hyperparameter tuning. So I'll come and say x train x test, y train y test equals to train test split. Then we're going to have x and what y. Test size equals to 0.2, and state is equal to 22. Let's say 42. So we split our data, then we'll now build. Now, this is where you are now going to use your when using GridSearch or randomizer, you don't do the normal model building. Let me show you how you're going to do it. So you have to come here and now define what we call params grid. So what you're trying to build here is what? You're trying to use a random forest classifier, right? So you have to know the different parameters that you want to tune. First, very important. So you can come here and look at them. Okay, n estimator. So I'll use this one. So I can use criterion, and let me just use n estimator, criterion, and max depth. And also know the kind of value each of these parameters can carry, all right? So I'll come here and define what we call params grid. So defining my params grid. I'll come and say params grid. Come on, and it should be a dictionary. So you come here and you say n estimator. So that's the first thing. N estimator. So remember that is a dictionary, so you have to put a list. So you try with 20 estimator first, then you try with 50, then you try with 100. So let's just use 3 because of time. So you also have criterion. So we have how many kinds? So you have to ensure that you know the values that you are using. So let's check here. So criterion Guinea, let's see other one. I think we have Guinea, we have entropy. So we are going to just try Guinea and what? Entropy. All right. So let's try Guinea and entropy, but you need to have an understanding of the different parameters there, because sometimes you might go into error because of there are some combinations that are not allowed. So you put it in a list. Okay, let's just try these two first so that it doesn't take so much time. Okay, so this is the parameters that we want to tune. We want to try a combination of this 20 and Guinea, 20 and entropy, 50 and Guinea, 50 and entropy, 100 and Guinea, 100 and so you now have 2 what raised to power what 3, if I'm right. That is 1 2 1 2 1 2. That is 6, or there's 1 2 3 4 5 6. That is 6 actually. 2 times 3, that is 6. So you have 6 combinations here. If please correct me if I'm wrong. So we have these 6 combinations here. So instead of you to create 6 different models, you can just do this. And after you've created your parameters, the next thing is to what? Now bring in your cross validation. Your grid search. So you come and say grid search, and you say grid. You create an object of grid search, right? So the grid search object takes different parameters. So it takes what we call estimator, and it takes what we call param. So these are the 2 important ones here: estimator and what? Param grid. So I'll come here and say estimator. So this estimator is the model you want to use. All right. So we can just put random forest classifier params grid equal to what? This params grid that we've already instantiate here. So come and paste it. Right. So these are the 2 important parameters in your grid search. Right. So there's another one called CV. You see CV is here. So the CV that I explained is here. You can change the cross-valid number of K food that you want. So if you scroll down, let's see, CV. So you can see here, none is the default. So it will use the default 5-fold cross-validation. All right. So you can now specify the number of foods if you don't want to use the 5-fold. So, but you just have to leave it like that most of the time. So once you do this, you okay, you ensure that you don't have any misspelled stuff there. Okay, and estimators. Okay, we should put this in. Okay. So an estimator. So you put it in string actually. You put the keys in the dictionary in strings. All right. So what is params grid? So param. Okay, there's no S here. Param grid. So once you've set up your grid search, what will you do now? The next thing is to what? Say this grid search object that you've initialized here. You come and see grid search dot fit on your X string and what? Y string. Instead of using random forest, Instead of using random forest classifier straight up on your S-string, you would use grid search on your S-string. So this is exactly how you position it. So you then press enter, so it will just train it. So you can see it's still training, it's taking time. You can see that it has finished training. So you can see the model that it has built here. So if you open this thing, you see the different parameters here, and you can see the estimator, random forest classifier. So it just shows you the summary of your model. So now you can now get the best params combination. So to do that, you can come and say grid search dot, there's a particular attribute called best params. So press enter, you see that to give you an answer. So criterion, the best parameter combination is what? Criterion equals to entropy and n estimator equals to 100. Do you understand? So this is the two parameters that you combine that will give you the best accuracy score. So you can now move ahead to now train your random forest classifier using these two combination. You come here and just put them here like this, and you can say random forest, and then you would say rf dot fit x train and then y train. So what was the, okay, sorry, it should be not the dictionary, equals to, yeah, come here, this one too, come here, come here. So you can train it, and then you can come here, and so I don't want to go into all this evaluation, but this is basically how you can get the best parameter combination, and then you can now use it in training your model. So this is hyperparameter tuning. Let's say you have, let's say you want to add more parameters here. Come here, let's see the other parameters we have in random forest. So we have max depth, all right, we have max depth, so we're going to add max depth. So we're going to say max depth, you say we'll try 2, 3, 4, 5, 6. We'll try this combination, all right, run it and come here and run our grid search. So that will take more time because we have more combinations. So for each of the combination, grid search is building a model using cross validation. So imagine how much is going on internally. So it's going to actually take a lot of time. And the funny thing is that these are few combinations. That sometimes you have more parameters, hyperparameters here, and even longer values to combine. So it's good. Sometimes it can take you up to 1 hour to actually train your model using grid search, or to get parameter combination using grid search. So you can see that it's still running. That was the disadvantage that we talked about using grid search, that it is time consuming because it goes through each of the combinations. Do you understand? So unlike randomized search, as we are waiting for it to train, let's quickly go to, okay, you can see it has finished training now. So if you look at this, you see the parameters here. And if you click on best param, you can see now the max depth has been included here. And then because of this, the n estimator have changed to 50. So this is the combination that will give you the best accuracy, that will give you the best performance of that model. So let's look at randomized search. So randomized search is still the same thing. The same process that you'd have to follow. You can just come here and define your params grid. So come here, so randomize search. All right, So come and say random search equals to randomized search. Sorry, not randomized. Okay, I've not imported it yet, so I have to come here and import it. Come and say GridSearchCV and RandomizedSearchCV. Right, enter. Come here and say RandomizedSearchCV, and then you'll see that it has a different it has a there's no attendance. Oh, okay, give me a minute, please. All right. I don't know what happened, but I've just taken a snapshot of everybody in the class right now. So, yeah. So please try to stay to the end because I'm still going to take another snapshot as well. I don't know what happened, but the attendance was supposed to be sent. I'd have to check to know what happened. All right. So let's just continue. So randomized search has what we call n-eta. So this n-eta is what is going to determine how many number of combinations it is going to go through. So you can see all the documentations here. So the n-eta here, it says number of parameter settings that are sampled. All right, so by default, it is what 10, but you can change it. So first thing here is what estimator. So you use what random forest classifier. Come and say params distribution. Param distribution. How is it spelled again here? Param distribution. Okay, so I should have comma. Oh. Yeah, please, let's just quickly. So param distribution, then you have to put this params grid that you created before. So the same thing, and n-eta. So n-eta, let's say 10, all right, or let's say 20. And then we'll enter, and then we'll come and say random search dot fit, say x train y train. Then you run enter. So you notice how fast this is compared to GridSearch now. So it should not take as much time as GridSearch. So, but depending on the number of eta you put here, it might take more time or less. So by default, it's usually 10, but as I've indicated 20 here, you might see that, let's see if this combination here is up to 20 to 2 times 3 times 5. So you can check 2 times 3 is 6 times 5 is 30. So this, using GridSearch, this is going to be 30 combinations. So you've indicated 20 here. So the difference is not really much, right? So, but if you have a whole lot more parameters and a whole lot more values, then you would actually start to notice the difference. So now you see that it has built the random search CV. So the same thing with GridSearch. The difference is just that it does not search the entire combination. That's it. So if I come here and say random search dot best params, you can see it gave me this. All right, it gave me this, and you can see this is different from what? It's different from the GridSearch one because it did not go through all the combinations. So random search might not necessarily give you the best param combination, but it is faster than GridSearch. So that's it for hyperparameter tuning. You can play around with it. You can add more values here. If you add more values here, 7, 8, 9, and all of that, you would take a lot of time, right? You can add more values, you can add more parameters to it, and just to check a lot of things. So this is how you can tune your hyperparameters. So in that question, I asked you to try for different number of K for KNN. You can use this hyperparameter search or hyperparameter tuning to do that instead of doing everything manually. If you get the particular combination that gives you best performance, you can now use it to train your model. So this is what we're going to be stopping for today. We've actually been able to cover everything as pertaining hyperparameter tuning. So so let's see. Okay, there's another attribute which is called best score, which I actually forgot. So the best score is going to show you the best. So you can see is what 96%. So this best score means accuracy in case of classification. So 96% here. All right. If I come to this grid search here to see grid search best score, is 96.04400439. This one is 96.48. So it's even, you can even see that random forest is I say random forest. Randomized search is giving a higher score. I don't know why, but that's what we can see from here. So depending on what you are doing, you should know which one to pick and which one not to pick. All right. So that's it for using GridSearch and randomized search for tuning your hyperparameter. It's actually very much efficient than the manual method that you would use. So that's it for today. So in conclusion, understanding overfitting, underfitting, bias and variance is crucial for building effective machine learning models. Hyperparameter tuning like GridSearch and randomized search helps in optimizing model performance. Balancing this aspect ensure that your model generalizes well to new data, leading to better predictions and insights. So the end goal of all this thing we are doing is just get a better model, to get a model that is performing very well. That is the end goal of all these things we are doing and we will be doing. You understand? So I believe you've all gotten an idea of how to tune your hyperparameters and what overfitting is, cross-validation, bias and variance, and bias and variance trade-off, and everything that we've looked at today. So we're going to be closing the curtain now, and I'll be taking questions. So if you have any question, please do well to ask, and after that, we'll call it a day. If you have any question, please indicate. All right, Nkechika Collins. Collins, please go ahead and ask your question. Unmute yourself, please, and ask your question.
Hello, sir. Good evening, sir. Good evening, everybody. Thank you, sir, for the teaching of today. My question is actually not based on today's teaching, but is on Google Colab. Is it possible that some companies will ask us to use Google Colab in place of Jupyter Notebook? As in, can we use Google Colab?
Yes, Google Colab is just another platform where you can write code, data science code. Yeah, if you know how to use Jupyter Notebook, then Google Colab is going to be very easy for you. It's just it just have a different interface. It's just like using Microsoft Word or Microsoft Excel and then you now want to get do a work for somebody or a company, and they're asking you to use Google Docs or Google Sheets. They are almost the same thing. It's just the different interface and some slight changes that were made. So it will not take a lot for you to just adapt to that platform. You understand? So that's just it. Google Lab is exactly like Jupyter Notebook, it's just a different interface.
Okay, sir. Secondly, my week 9 assignment, I couldn't do it because of health challenge. Please, can I still submit this week?
All right, just send me a DM, please. Send me a DM.
Okay, sir. Thank you, sir.
All right. Aderemi, please unmute yourself and ask your question.
Good evening, sir. Thank you for the lecture.
Good evening.
Sir, please, there is a question that I want to ask pertaining to the scientists that normally collect data from field, like from yam, cassava, all these crops that we do collect data from. So how can we import it to the Python? Because I've not seen you are the data you are using is your ready-made own. So I want to know how we can import the data. Sir.
Once you gather data from any field, you usually put it in a file. Sure?
Okay.
Where
Yes,
do you
sir.
store your data? Where do you store the data you collect from the field?
We create folder and we normally store it in Microsoft Excel.
Exactly. Sure? We've been importing CSV file from using pandas
Yes.
previously when we were doing pandas and all of those other things. So the same way you import those files, is the same way you import this one too, right? So if
Yes,
the file is CSV file, you import it. If it's in Excel, you use a different function in pandas that can import Excel file, right? It's called read
sir.
Excel. Okay, so that is just straightforward. There is no big deal with importing your data.
Okay, sir.
So I hope you are clear.
Yes, sir. Thank you,
All
sir.
right.
I'm grateful, sir. Yes, sir.
All right. Thank you very much. Any other question? Any other question? All right. Akinlabi, unmute yourself and ask, please.
Good evening, everyone, and thank you for the lecture, sir. So my question is based on last assignment, and when you ask us to use different for k neighbors, that are going to use different numbers to check for k neighbors. I used range. So I said for k in range in bracket, does it make sense or is wrong, sir?
Yeah, that makes a lot of sense. It's actually another way you can specify the values you want. You understand? So if you don't want to start typing out everything individually, you can just use range to create a list of values. So it's very nice, right? So it's another way of getting the values in your params grid. So yeah, it's done a lot. It's actually done a lot. So you can just say range this and this, or if you are, I don't know how you did that. I've not gone through all the assignments yet, but yeah, it's a valid way. It's a valid way. So let me just do a quick illustration so you see what I mean. So let's see. So for instance, now let's say you want to get this max depth now. You want to get maybe max depth from 2 to 10. Instead of writing this particular thing, you can just say range 2 and 11. All right. So this will basically create a range for you. And this, you know what a range is. It's create numbers from 2 to 10. So it's the same thing as writing 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can just use range here instead.
Okay, so anyone you want to do, you can just convert it to a list if you want. But yeah, you, as long as you understand Python, you can do whatever it is you want to do. You don't necessarily need to follow a rule or a particular method, right? So because I use a method in class doesn't mean there's no other way to do it. So yeah, thank you for that question. So yeah, that is the guys going to be it for today. I think the attendance just dropped now. Right. Let me confirm. I think the attendance just dropped now, so please do well to go through the attendance. So I think there's one more person. Now let's take this last question. Come on, please ask your question or meet yourself and ask your question.
Good evening, sir.
Yeah, good evening.
Yeah, thanks for a lot for the lesson. I just want to ask about this thing when you were talking of the bias and the variance. So I want to know if I was asking if there is a particular score that you use to know whether the variance is too much or too high or is too low. Like maybe a scale of maybe 5. Maybe if the difference is like maybe like 5 or 10, then you can know that yes, this particular variance is too high or too low, or maybe it's just subjective. Where you just decide that whether it's too high. I don't know how to put it, but I don't know if
I get
it's
the
just.
question. I get the question. You've answered yourself already. It's actually subjective, right? It's subjective, and it's also based on the task you are doing, right? So there's really no particular rule that gives you a range or all of that. It's subjective. So once you see the difference, you should know, like based on your knowledge of data, what you are doing and the tags that this range is actually too much. That means it has high variance. So this is okay. The difference is not bad. It's okay. And then you can conclude that it doesn't really have high variance. So it's purely subjective. That is just what I'm going to answer to that.
Okay, sir. Thank you, sir. And I want to take a permission, because this week I'll be traveling somewhere that I'll not be somehow allowed to carry my PC along. So maybe the assignment, if there's a way you can extend the submission date for me.
No problem. Just you can remind me in my DM so that I'll take note of that.
Okay, thank you, sir.
All right. Okay, so that's going to be it for today. Thank you very much for sticking to the end of this class. This is the second to the last week. Next week is going to be the last week. And if there's another thing that might come up, then we might just hold a class for that. But officially, we'll be wrapping up with classes next week, and then your project is going to ensue. But if we're not able to cover everything we want to cover next week, then we might actually have to spill over to the other week. Right. So I hope you all enjoyed the class and yeah, you were able to get something out of it. So please do well to write out those things you learned from the class as you always do, and have a nice and splendid night and enjoy the rest of your day, and also do have a wonderful week ahead. Thank you very much.